let's look at this problem. I have a double integral, so I'm given integrand f, in this case equals f of x y equals negative 2y over the region R, and R is the region bounded by these two graphs. Okay, so for us to be able to apply the Frobenius theorem so that we can evaluate the double integral, we need to have some idea of what the graph looks like, and then use inequalities to describe this region R, right? Okay, so first of all, y equal to minus 4x squared. We know this is a parabola because the degree power 2 here, and we know this parabola is opening downward because of the minus sign. So roughly speaking, I have a 4 minus x squared over here. All right, and then I have a line because this is a x to the power 1 function, a polynomial of degree 1, and because of the minus sign, the minus 1 times x, so I know it's gonna be a line that's looking like this. Okay, so here I have y equal to 4 minus x, and again, this graph is not accurate. This is for illustration. So over here we see that these two curves, they give you, they bound you a region for you. So the R is this region, okay, the region bounded by these two graphs, and our goal is to find inequalities to describe this region R. So as far as we can see, for any x value, okay, so this is x value, then your y will be bounded in between the associated 4 minus x, which is this point on the line, and this point on the parabola. So that's 4 minus y squared. So you only care about the y values in between these two graphs. So you have y bounded below by 4 minus x, from above by 4 minus x squared, right? But we're not just looking at any arbitrary x value. We only care about the x values starting from this intersection point to this intersection point. Okay, so from the graph we know that we're supposed to have two intersection points, but in reality we don't know where they are yet, so we have to work on that. All right, so set 4 minus x squared equal to 4 minus x, and solve for x. So what we got? So we get x squared minus x equal to 0, which tells us x times x minus 1 equals 0. So we have two solutions. One is x equal to 0, and the other is x equal to 1. Right. So this point is supposed to be over here. Okay, so because it's x equal to 0. And then over here it'll be x equal to 1, right? That's what we know. So altogether, we see that R is the region where x is between 0 and 1, and for any x in this region, y would be between 4 minus x and the 4 minus x squared. So this is very important, because now with this expression, we will be ready to rewrite the double integral in terms of a iterated integral. So first of all, I never bother the integrand. So don't do anything with the integrand. Just focus on converting the integral, okay? Then here we're supposed to integrate with respect to y first. So 4 minus x on the bottom, 4 minus x squared on the top, dy, okay? Because you're going vertical direction. Then you scan through this y direction from x equal to 0 to x equal to 1. So 0 to 1 for the x. Okay? So the order of integration is very important. All right? When you have this expression, it's dy first and then dx. All right. So then once you have that, the following is a straightforward computation. So 0, 1, antiderivative of negative 2y would be minus y squared. And then 4 minus x, 4 minus x squared, then dx. So plugging in, I have minus 4 minus x squared, whole thing squared, minus negative 4 minus x squared, and then dx. Okay, so then over here I have minus 16 plus 8x squared minus x to the power 4 plus, okay, minus gives me plus, okay, then I work out this 4 minus x squared, so that's a 16 minus 8x plus x squared. Okay, so this is a straightforward computation. Don't worry too much about it. Okay, so now I have 0, 1 that start from higher degree to lower degree. So negative x to the power 4 plus 8x squared plus x squared. So total that's 9x squared. And what's the next? Minus 8x. And I work on integrating this polynomial here. Right, okay? So I'm not done yet, but I'll let you finish the problem, okay? So the key here is we are given a region R bounded by two graphs, and by solving the equation and looking at the graph, we're able to express the region R using inequalities of x and y, and because of this, together with the Frobenius theorem, then we can write the double integral in terms of iterated integral, and the rest is really just a straightforward computation, and you can do it, okay?